1. Which of the following is a critical factor when mentoring a robotics engineering team in a complex project? A. Maximizing individual contributions. B. Encouraging competition among team members. C. Fostering open communication and collaboration. D. Focusing solely on the technical skills of each member. 2. When designing a curriculum for robotics engineering, what is the primary focus to ensure adult learners remain engaged? A. Providing detailed theoretical concepts without application. B. Ensuring the content is directly relevant to real-world applications. C. Overloading with technical jargon and complex equations. D. Focusing primarily on individual learning rather than group collaboration. 3. Which of the following regulatory bodies is most likely to influence the design and implementation of robotics systems in healthcare? A. American Medical Association, AMA. B. Occupational Safety and Health Administration, OSHA. C. Food and Drug Administration, FDA. D. National Institute of Standards and Technology, NIST. 4. Which evaluation method is best suited for assessing a robotics engineer's ability to design a fully functional robotic arm? A. Oral exams. B. Peer reviews. C. Practical hands-on testing. D. Multiple choice written tests. 5. What is a primary benefit of using a competency-based learning approach in robotics engineering education? A. Students are required to memorize large amounts of information. B. Students can progress at their own pace based on their mastery of specific skills. C. The course duration is reduced significantly. D. It eliminates the need for any evaluations or tests. 6. What is an essential skill for a robotics engineer when working on a multidisciplinary team? A. Knowledge of only robotics hardware. B. Strong leadership and team management skills. C. Basic knowledge of programming languages only. D. Focus on individual performance. 7. Which of the following would be the most important consideration for a robotics engineer designing a system for use in a hazardous environment? A. Aesthetics of the robotics system. D. Regulatory compliance and safety standards. C. Speed of operation. D. Simplicity of the programming code. 8. In a robotics engineering curriculum, which method best fosters collaborative learning among adult learners? A. Assigning individual projects with no team interaction. B. Incorporating group projects with shared goals and responsibilities. C. Focusing on theoretical lectures with limited practical application. D. Using only self-paced online modules without interaction. 9. What is the role of ethics in the design of autonomous robots? A. Ensuring robots can outperform human workers. E. Fostering human-robot collaboration while adhering to ethical guidelines. C. Allowing robots to make decisions independently without human input. D. Limiting the complexity of robot design to avoid ethical concerns. 10. What should a robotics engineer prioritize when presenting a project to a non-technical audience? A. Detailed technical specifications and calculations. B. Clear visual representations of the system's functionality. C. In-depth explanations of programming languages used. D. Focus on the history of robotics. 11. Which of the following is most important for a robotics engineer when selecting components for a robotic system? A. The cost of the components alone. E. The performance, reliability, and compatibility of the components. C. The aesthetics of the components. D. The number of components required for the system. 12. How should a robotics engineer evaluate the success of a newly developed robotic system? A. By measuring its performance against project goals and requirements. By comparing it only to similar systems in the market. C. By considering only user satisfaction. D. By reviewing the project timeline and budget. 13. What is the most effective way to communicate complex technical information to adult learners in a robotics engineering course? A. Using highly technical jargon to establish credibility. B. Presenting information through hands-on demonstrations and real-world examples. C. Focusing primarily on written lectures without practical application. D. Using passive methods like video tutorials without interaction. 14. Which of the following strategies is most effective for mentoring a robotics engineering student with limited prior experience? A. Assigning them to complex projects immediately. B. Providing clear, step-by-step guidance and frequent feedback. C. Encouraging them to learn through trial and error without much support. D. Ignoring their progress to encourage independent learning. 15. Which of the following best describes the concept of safety interlocks in robotic systems? A. Features that prevent unauthorized access to the robot's programming. B. Mechanisms that ensure the robot stops functioning if safety conditions are violated. C. A programming language used to control robotic systems. D. Hardware used to increase the speed of the robot. 16. How should a robotics engineer approach the challenge of ensuring their system is adaptable for future technological advancements? A. By designing a rigid, non-modifiable system. B. By using open-source software and modular hardware components. C. By limiting the system's functionality to basic tasks only. D. By avoiding any software updates after the system's deployment. 17. When evaluating a robotic system's impact on a manufacturing process, which metric is most relevant? A. The system's total cost of development. B. The system's operational efficiency and uptime. C. The appearance of the robotic system in the factory. D. The number of employees displaced by the system. 18. What should a robotics engineer do if they encounter an unexpected safety issue during testing? Ignore the problem and proceed with the test. B. Immediately stop the testing process and evaluate the risks. C. Continue testing until the issue becomes critical. D. Ask the testing team to handle the issue without reporting it. 19. In what way can robotics engineers best use feedback from end users to improve their systems? A. By ignoring end-user feedback in favor of design specifications. B. By conducting thorough testing and adjusting the system based on user input. C. By focusing only on the initial requirements of the project. D. By only making minor cosmetic adjustments based on feedback. 20. What is the primary purpose of conducting a failure modes and effects analysis (FMEA) in robotics design? A. To reduce the total cost of development. B. To identify potential failure points and their consequences. C. To speed up the design process. D. To create a marketing strategy for the robot. 21. What is the most significant challenge when designing a robot for use in healthcare? A. Ensuring the robot looks appealing to patients. B. Adhering to strict regulatory standards for medical devices. C. Maximizing the robot's speed and efficiency. D. Designing the robot to be as large as possible. 22. How can robotics engineers best ensure that their designs are compliant with industry regulations? A. By designing systems without considering regulatory standards. B. By constantly updating the design to meet changing regulations. C. By using a generic design without understanding specific regulations. D. By outsourcing regulatory compliance to third parties. 23. What role does simulation play in the development of robotic systems? A. It allows engineers to test designs without physical prototypes. E. It guarantees that the system will work flawlessly in real-world conditions. C. It eliminates the need for physical testing entirely. D. It is primarily used to test the system's visual appeal. 24. What is the key benefit of using a systems engineering approach in robotics design? A. Focusing solely on the mechanical aspects of the robot. B. Ensuring all aspects of the system work together efficiently. C. Designing a robot without considering its real-world applications. D. Limiting the scope of the system to reduce complexity. 25. In terms of communication, what is a critical skill for a robotics engineer working in a cross-functional team? A. Ability to deliver long, complex reports without feedback. B. Ability to communicate technical information clearly to non-technical team members. C. Focusing only on written communication and avoiding verbal interactions. D. Avoiding any form of communication until the project is complete. 26. Which of the following best represents an essential skill for a robotics engineer in a rapidly changing technological environment? A. Relying on outdated software and hardware to ensure consistency. B. Continuously learning and adapting to new technologies and methodologies. C. Focusing only on the immediate project at hand without looking at future trends. D. Avoiding collaboration with external experts. 27. How can robotics engineers ensure the long-term reliability of their systems? A. By designing systems that are highly specialized and limited in functionality. B. By focusing only on the initial development without considering future needs. C. By creating systems with redundant components and self-monitoring capabilities. D. By keeping the system design as simple as possible.